Isn't it crazy that everything around us, including the oceans, the clouds, the mountains, your phone, even your brain, is made up of the same 118 elements? That's it. Only 118 building blocks make up the entire universe. But do you actually know what they are? Let me teach you science today in a fun way. Now, let's start from the beginning. The periodic table is arranged by atomic number, which means the number of protons in an atom's nucleus. Hydrogen is number 1 because it has 1 proton. Helium is number 2 with 2 protons, and so on. This number determines everything about an element: how it behaves, who it bonds with, how reactive it is, or how chill it wants to be. The table is also arranged in groups, which are the vertical columns, and periods, which are the horizontal rows. The elements with the same properties are placed in the same group. They share the same properties because they have the same number of valence electrons, which are the outer electrons that decide how an atom reacts. Let's meet the first group. It's the alkali metals. These are lithium, sodium, potassium, rubidium, cesium, and francium. They all have 1 electron in their outer shell, and they hate that. That single electron makes them unstable and eager to give it away, so they are superreacted, especially with water. Let's say you drop sodium in water. It will fizz and pop. If you do the same with potassium, it will set off fireworks. Francium is the rarest and most unstable of them all, so we barely ever see it before it decays. All alkali metals are soft and silvery, and they get more reactive as you move down the group. Right next to them are the alkaline earth metals. This includes beryllium, magnesium, calcium, strontium, barium, and radium. These elements have 2 electrons in their outer shell, which is not as dramatic as the alkali metals, but still reactive. Now we head into the big middle section of the table, which is the transition metals. These include iron, copper, silver, gold, platinum, nickel, zinc, and a whole lot more. This is the largest block on the table. Transition metals are known for being strong, hard, good conductors of electricity and forming colorful compounds. They also have partially filled d orbitals, which just means they have more complicated electron arrangements and can behave in flexible ways. That's why they make great alloys, magnets, and wires. Now slide over to the post-transition metals. These include aluminum, tin, lead, bismuth, indium, and thallium. They are softer, melt more easily, and are not as strong as the transition metals. On the zigzag line between metals and non-metals, we meet the metalloids. These include boron, silicon, arsenic, antimony, tellurium, and polonium. They are the weird in-betweens. It means sometimes they act like metals, sometimes like non-metals. Silicon is the king of electronics. Without it, there would be no phones, no computers, and no internet.
If you look at arsenic here, you should know that this little fella is famous for murder. It is toxic in larger doses. And polonium is radioactive and once used to poison political targets. Now comes the halogens. This is group 17, which includes fluorine, chlorine, bromine, iodine, and astatine. These are the second most reactive group on the table. It's because they are 1 electron short of having a full outer shell. That makes them desperate to grab one. After all that reactivity, we reach the group that is the calmest of all, the noble gases in group 18. These include helium, neon, argon, krypton, xenon, and radon. Why are they called noble? Because they don't react with anyone. Their electron shells are already full, so they just sit around being stable. Let's go back to the top for a second and talk about hydrogen. It does not belong neatly in any group. It only has 1 proton and 1 electron, and it is the most abundant element in the universe. Stars burn hydrogen. It is the lightest of all elements and doesn't behave like a typical metal or non-metal. It's sort of a loner. Right next to hydrogen is helium, atomic number 2. Now you might be thinking, why do elements increase by 1 number each time? That's because each step adds 1 more proton to the nucleus. That's it. It's that simple. 1 proton is equal to 1 step to the right. Let's talk about the most common or abundant elements of the periodic table. First of all, there is carbon, which is special as it is the basis for all life. Carbon atoms can make long chains, rings, branches, and even cage-shaped molecules. That's why organic chemistry is based entirely around it. Then there is nitrogen and oxygen. Nitrogen makes up 78% of the air around you, and it's essential for proteins and DNA. Oxygen makes up 21% of the air, and is what keeps you and every other living thing alive. At the very bottom of the periodic table, we have 2 special rows. First, the lanthanides. These are elements 57 through 71. They are shiny, silvery, and used in electronics and magnets. They have similar properties and are tricky to separate. That's why they usually get shoved down below the main table. Then come the actinides, from thorium to lawrencium. These elements are heavy and radioactive. Uranium and plutonium are used in nuclear power and weapons. Others, like americium, are in smoke detectors. Some, like einsteinium and fermium, were made in labs by smashing atoms together. They are so unstable, they fall apart in seconds. After that, we reach the super heavy elements, like rutherfordium, livermorium, and oganesson. Most of these were made in the lab and don't last long enough for scientists to do much with them, but they complete the table, for now. Oganesson is number 118, and it officially closes the periodic party. So there you have it, the periodic table. Which element fascinates you the most with its properties? Before you go, don't forget to subscribe for more quick and casual explanations. I'll see you in the next video. Goodbye.